All right, so today we are covering section 14, inverse trigonometry, okay, and solving triangles is what we're going to talk about today. So first of all, what is an inverse? Well, an inverse function is a function that reverses or undoes a function. Some examples here: squaring and square rooting, adding and subtracting, multiplying and dividing. Okay, so historically here, when we've been solving equations to get x by itself, we have been focusing on undoing the operation. Well, so far we have solved for missing sides. Undoing or finding the angle is the inverse part. So today you're going to have two sides of a right triangle and you're going to be able to find the acute angle that provided that ratio, because it's going to be an inverse. So inverse trigonometry is going to be used to find missing angles. We must have two or more sides. If you want to underline the word sides here, I kind of had a typo on this, and then this blank isn't necessary. We must have two or more sides of a right triangle. And so to verbalize what the inverses are, and we don't use this terminology very much, I usually just say sine inverse, but you might hear or see in a textbook or on the internet sometime that they might call that inverse of sine arc sine, arc cosine, and arc tangent. Again, just some terminology I want you to be familiar with that you might need in the future. Okay? On your calculator, okay? On your calculator you have your sine, cosine, tangent buttons, and to get the inverse, you're going to use the second key. So it's going to say sine to the -1. That's arc sine or sine inverse. Cosine to the -1, tangent to the -1. So at this time, get your calculators out if you haven't already, and just see if you can find those keys and make sure that you can, and then we're going to do some practice here, typing them in. Yeah. Alright, so friendly reminder, on a graphing calculator, you should check your mode. Okay? So on your graphing calculator, you need to check the mode. And make sure that we're in degree mode. If a calculator gets reset or straight out of the package, those default settings are in radians. I clicked my calculator here. It's taking a little bit to load up. There it comes. So again, on your calculator, you have your mode button here. You want to make sure that you're in degrees, okay? And then to get out of this screen, you just hit second mode, which is the quit screen. All right, so on our notes here, we wanted to test some of these, just working with our calculator. So it says to find each angle, okay? So right now, it says that tangent of A is 2.0503. Now, I want you to think for a second with me. What does this 2.0503 mean? What is tangent? Tangent is the blank divided by blank. Opposite divided by adjacent. So whatever those numbers, when I take those and I divide them, I'm getting this number, okay? So in your calculator, what we're going to type here is tangent inverse. So we're trying to get A by itself. So A is equal to the tangent inverse of this 2.0503, okay? Today we're going to leave this as a fraction. We're not going to actually divide it out and get these decimals. When we go to solve, we're going to leave it. So right now it's just some calculator practice. So in your calculator, I'd like you to type tangent inverse. Your calculator opens up that parenthesis for you, 2.0503. Now notice it says to measure to the nearest degree. So that is going to be my preference for you this year, is if you are ever solving for a missing angle on a worksheet, okay, we're going to go to the nearest whole degree. From here on out, unless I say otherwise, if you're solving for a side, we're going to continue to measure to the nearest tenth of a degree. Or, excuse me, tenth of a, whatever the side measurement is, inch, foot, whatever the unit is. So would you agree that we're approximately getting 64 on A? Okay. So then on B, to get Z by itself, you would type in your calculator cosine inverse of this 0.1219. And we're approximately getting to the nearest whole degree. It's approximately 83 degrees. Now on C, y is going to equal the tangent inverse of this 0.6494, and I approximately am getting 33 degrees. And then on D, to get u by itself, we would type the sine inverse of 0.8746. And I approximately got 61 degrees. Does anyone need any help with their calculator? Were we able to get all four of those answers? Back there? Right here? Good? All right. So let's get into the real mathematics here of inverse trigonometry. So on example 2a here, I have this question mark. I want to find this angle here. So we need to, I heard someone just a moment ago write down that mnemonic device. Okay? What can help us? We know sine is opposite hypotenuse. So, TOA. So that can help us know what fraction we're going to set up here. So I'm missing this angle here. Okay, I'm going to call it a theta. It's like a capital cursive O. We've used that terminology a little bit. So I want to know from, on this triangle, would you agree 55 is the hypotenuse? And from theta here, this missing angle, 51 is the opposite. So what trig function uses opposite and hypotenuse? Sine. So we're going to write sine of theta equals, and we're just going to leave it as a fraction like I was talking about a minute ago, 51 over 55. And now our calculator gets to do all the work. I want theta by itself. So I'm going to rewrite this. I'm going to say that theta equals the sine inverse of 51 over 55. And you would just type that in your calculator using your divide key. So I'm going to hit second sine. Was 51 in my numerator? Divided by 55. Okay. And rounding to the nearest whole degree here, we would see that this angle is 68 degrees. Okay. Let's try another one together. So here on B, again my question mark, I'm going to relabel that theta, my missing angle. On my right triangle here, 56 is my hypotenuse, and from theta, 52 is now my adjacent. And so to find theta, I'm going to say that cosine of theta equals 52 over 56. And to get theta by itself, I'm going to write cosine inverse of 52 over 56. Now, a lot of you are very bright math students, okay? And you get to the point where you are not wanting to show your work. I get that. I need one of these two things on your paper, either the original or what you type in your calculator. If you don't have the right answer, I have no idea what you typed in your calculator. When you look back at it, if you get it wrong, you won't know what you typed in. So I need one or the other. You don't have to write both. Is that okay? All right, so in our calculator, we are getting 22 degrees. Any questions or concerns about A or B? Clarifying things? Okay, so then on B here, oh, we already did B, excuse me. A and B. On example A, what's interesting here on this problem, guys and gals, you have all three sides. So you can actually use any of the trig functions to find, and again, I'm going to call this question mark theta. Okay, so let's label this out. From the right angle here, I have 55, which is my hypotenuse. 44 would be the opposite, and 33 would be my adjacent. Would you agree if I wanted to use tangent, what I'd be typing into my calculator would be tangent inverse of, from theta, TOA, it would be 44 over 33. Or I could use sine. From theta, I could type 44 over 55. And if you type all three of these in your calculator, you should get the exact same answer each time. And cosine, I could also use adjacent 33 over hypotenuse 55. So on this particular problem, you could use all three or any of them, and our answer should have been, would you agree, 53 degrees. Okay. Sometimes you get all of that information, and you get to pick any of them. But again, on this one, I don't have that luxury. Let's go to 3b. I have theta here. From theta, 29 is the opposite side. 38 is my adjacent. And so which trig function am I limited to here? Tangent. Tangent of theta would equal 29 over 38. And tangent inverse of 29 over 38 in my calculator would leave me with, do you guys agree, 37 degrees? Okay. This is example 4A and B, where the directions are to solve for all the triangle. So that means that you need to find all missing sides and angles. So hopefully you would agree here. This would be side A down here. So we need side A. We also need the measure of angle A and the measure of angle B. So we have a couple options here. With little a here, what we could do is use the Pythagorean theorem because we have two of the three sides. So hopefully you would agree a squared plus 19 squared needs to equal 27 squared. And so if I do the math here, I would end up with a squared equals, square these, subtract the 19 squared over, I get 368. And the square root both sides, this little side a is going to be 19.2. So then to get angle A and angle B, I am going to have to use trig inverse. I chose to use cosine to find angle A. So the cosine of angle A equals 19 over 27, the adjacent over the hypotenuse. And to get that inverse, or to get that angle, we're going to use inverse. So angle A equals the cosine inverse of 19 divided by 27. Typing that into your calculator, you should get that the measure of angle A equals
Allison Rosenberger, please report to the attendance window.
45
Allison
degrees.
Rosenberger to the attendance
Now,
window.
when you have now that angle A is 45 degrees, angle C is 90, we can use the idea that triangles add up to 180 degrees. Okay, so 180 degrees minus 90 minus 45, that leaves us with 45 degrees for angle B. So the measure of angle B is 45 degrees. So to finish up here on example B, we have all of the sides. So what we only need to find is angle G and angle E. And you have all three trig functions available to do that. So I just chose to use sine. So from angle E, I know that the sine of angle E was going to equal the opposite divided by the hypotenuse, 24 over 74. And so then the sine inverse of 24 over 74 is what we can type in our calculator. And the measure of, I'm going to have to type this in real quick, sine inverse. Maybe I do that again. So sine inverse of 24 divided by 74 is 18.92. And that would round to 19 degrees. So the measure of angle E would round to 19 degrees. And then, guys and gals, if I know that this is 19 degrees, I can subtract from 180, 180 minus 90 minus 19. I know then that the last angle is 71 degrees. So the measure of angle G is 71 degrees. All right, so we have two examples left with C and D. If you want to go ahead and complete those. All right, so let's finish out these last two examples here for C and D. So as we were saying a moment ago, we could find side O and side N, and then we would need angle N before we were done. So with the 35 that's given, if we wanted to solve for that side O first, we would use sine. Okay, so sine of 35 would equal 5 over x. When the x is in the bottom, we swap them, right? And so x or O is the side that we're finding right now. So side O would equal 5 divided by the sine of 35 in our calculator. And to the nearest tenth is what we're measuring sides to. And I'm getting 8.7. So then to find side N is the adjacent side and 5 is the opposite side, so I used tangent. So tangent of 35 equaled 5 over N for TOA. And again, when the variable's in the bottom, we swap them and divide. So side N is going to be equal to 5 divided by the tangent of 35. Okay. So again, to make sure that I can see if you made a mistake, you need one of these two wrote down. Okay, just like I talked about in the inverse trig today, you need one of these two wrote down on your paper so I know what you typed into your calculator. And so side N I got was 7.1. And then to find angle N, we were going to have 180 minus 35 minus 90, and we know that the measure of angle N is then 55 degrees. Okay, so that's all of the three parts that we're missing. So on here on example D, we have side H and side O. To find the angle O, if you want to do that first, you can. So 180 minus 90 minus 36, we know that the measure of angle O is going to equal 54 degrees. Now, just in case we make a mistake getting this, I will not use 54 in my trigonometry. Okay, so I'm going to for sure use the 36 that's on the screen here. So sine of 36 could help me find this opposite side H. Okay, and so I would have H over 10. And then remember when the number's in the bottom here, to get H by itself, you multiply both sides by 10. So what I'm typing into my calculator is 10 times the sine of 36. And I got 5.9 for that value. And then to find the last side here, side O, using the 36 and the 10, that was going to be cosine. I confused myself because that's side O, and I was thinking opposite. I'm like, I've already used sine, so maybe should have used some different letters beside S, O, and H to label that triangle, since that is our acronym for SOHCAHTOA. Anybody else get confused with that? Okay, so good. Cosine of 36 helps me find side O here because of the label for that triangle. X over 10 is what that is equal to. And so again, not X, but O, I should say. I sometimes call these missing sides X's and Y's. So this is, again, side O. So O equals 10 times the cosine of 36. And when you type that into your calculator, I got that it rounded to 8.0. Everyone agree with that? Or did I stop writing it down on the calculator? 8.1? 8.1. I didn't write the .0, I just have an 8, so I figured I did not finish that problem. 8.1. All right, so that concludes section 14 note.